The greatest minds of the day gathered here at the prestigious Academy of Sciences in Paris to brainstorm a solution. They decided to base their new system on something universal and unchanging: the Earth. It was the birth of metrication. The first unit they fixed was the meter, basing it on 1/10,000,000th of the distance between the North Pole and the equator. The next was the kilogram, and the task was given to the father of modern chemistry, Antoine Laurent Lavoisier. By day, he was a wealthy tax collector. By night, he was the greatest chemist in the land. The French visionaries behind the metric system wanted all the new measurements to be linked, so they came up with an elegant solution. The new kilogram was to be equal to the weight of 1 perfect cubic decimeter of water, a litre.
The idea was very simple. Anybody with a meter ruler and some water could create their own kilo. But making a kilo based on the weight of a cubic decimeter of water turned out to be much more difficult than they thought. Now, I've got 2 perfect decimeters of water here. The trouble is that these don't weigh the same amount. The colder water weighs 998 grams, whilst the hotter water, 957 grams.
Because the hotter water is, the less dense it is.
And that's the trouble, the weight depends on the temperature. Not only that, it'll depend on what impurities are inside the water, what the atmospheric pressure is, how far I am above sea level. There's a real problem with trying to define the kilo based on the weight of water.
Lavoisier came close to solving the problem of how to accurately weigh water. But his brilliant career met an abrupt end at the hands of the guillotine on the 8th of May, 1794. His tax-collecting day job was his downfall. Next to take up the kilo challenge were scientists Louis Lefebvre-Junot and Giovanni Frabroni. 4 years later, they finally perfected how to measure a cubic decimeter of distilled water. A master metal kilogram could finally be cast.
And on the 22nd of June 1799, they presented their prototype kilogram to the nation. Called the Kilogramme des Archives, it was made out of the new wonder metal platinum. Soon, kilogram clones, as well as copies of the meter bar, were being sent to villages and towns across the nation to bring uniformity to the French Empire.
Their vision was brilliant, but there was a flaw.
The trouble was that pure platinum, although resistant to air and water, is actually rather soft and prone to damage.
And that meant bits were easily knocked off, gradually rendering the hundreds of cloned kilos inaccurate. The Academy's grand idea was slowly being eroded. It would take nearly 70 years to realise a new, more stable master kilo, and then a set of clones would be needed. London metallurgists Johnson Matthey were given the order to produce 250 kilograms of platinum mixed with strength-giving iridium. It was a big order, worth £2.2 million at today's prices. The man in charge of production, George Matthey, the world's leading expert in casting platinum, offered to make the kilos at his state-of-the-art furnaces at Hatton Garden. But French pride intervened, insisting it happened here at the Conservatoire in Paris.
It was a disaster. The platinum got contaminated by iron, rendering the whole consignment useless. It was a huge embarrassment, both for French pride and their pockets.
But it wasn't the death of the kilo or the metric system. With international trade booming, the benefits of having one common measurement system were clear for all to see. And in 1875, diplomats from 17 countries met here in Paris and agreed to formally adopt the metric system. With great zeal, a new kilogram master was commissioned. The order once again went to Johnson Matthey, and this time George Matthey was finally allowed to cast the most accurate platinum and iridium kilo ever made. Christened Le Grand Quai, it was consigned to a specially made vault at a newly established international centre of measurement outside Paris.
And here it is, the Bureau International des Poids et Mesures, the BIPM, or in English, the International Bureau of Weights and Measures. And this is really international territory. It's kind of a mark of how important measurement is to the world, that we've created a UN of measurement.
From the beginning, the BIPM's mission was to make sure measurements were consistent throughout the world. This is the building that was once home to all the world's master measurements. Today, most have been retired, replaced by new definitions based on the universal and unchanging laws of nature, like the speed of light and the movement of atoms. Le Grand Quai is in fact the only artifact that is still in use, a measurement dinosaur.